Logarithmic equations. Question 1. Find domain of following functions. Well, solving logarithmic equations means that you have log functions on either one side at least of the equation, and you have to deal with the log function. Now, log functions have restricted domain. So it's important here to understand what is the domain of given log function. So we have first 4 questions here which will give you kind of practice on finding domain of a logarithmic function, okay? And then we'll move on to solving equations involving log. So the first one here is quite simple for you, which is f of x equals to log to the base 2 of x. Now, as you know, x should be always positive, greater than 0. So that is the base, correct? Now, x could be given in different forms of functions as written here. So the idea here is that always make these things greater than 0. This is called the argument of your log function, correct? So here, when we say what is the domain, then we are trying to find out the permitted values for x, the values which x can take for which we can find the log, right? That is what we are trying to find. Or, in other words, we are trying to find restrictions, the values which x cannot take, right? So eliminate those values. So that is how you're going to look at these 4 questions, right? The first one is f of x log to the base 2 of x. Now here, x should be greater than 0, and that becomes the domain of our function. This could be written as 0 to infinity, that is one notation, which is interval notation, or we could write this as an inequality, which is here x greater than 0. Or it could be written in the set form. We say x belongs to real numbers where x is greater than 0, correct? In the set, right? So that is the x form, and normally when we say domain, we write d of x. So x is our normal variable which is independent variable, correct? So domain is all the values which independent variable can take, correct? So for this function, x, the independent variable, can take all values greater than 0. 0 is not permitted and negative numbers are not permitted. That is the other way of looking into it, correct? Now that's how it is. Let me also show you with the help of a kind of sketch which will help you understand what we are talking about. So if I sketch the graph of y equals to x, just a straight line. Y equals to x is a straight line like this, right? You see, your straight line is positive after 0, correct? So that is my x-axis, that is my y-axis. The straight line is positive on the right side of 0, correct, when x is greater than 0. So you can find log of x only on that side. That becomes your domain. This is another way of looking into or solving these kinds of problems on domain. You can sketch your function and see for the result, okay? So that is how we'll do part A. Let's move on to part B. G of x equals to log of to the base square root of 3, and the argument is minus 2x. So this time first let me sketch minus 2x, correct? So that will give me an idea of how that function should look like. Minus 2x means x and y intercepts are zeros, right, at the origin, and it is slope of minus 2. So it's a line kind of like this, going like this, correct? That's our line. Now if you see, this line is positive only on the left side of origin, right? And so we say, well, x should be less than 0 for this function to be positive, right? Or the argument of log to the base 3 will be positive if x is less than 0. So that is the solution, correct? You could do with inequalities also. Let me show you with inequalities. When I write that I want minus 2x to be greater than 0, then how will I deal with minus? I need to divide by minus both sides. When I divide by minus on both sides, what happens? 0 divided by minus 2 becomes 0. But what happens to the sign? sign interchanges. You see that? That is a very critical step. And many students at times don't understand that step. That if you multiply or divide by negative in an inequality, then the sign of the inequality changes. Well, does it make sense to you? Well, at times it doesn't. So let me give you one particular example. Let us say you know the number 7, right? Now 7 is greater than 5. You know that, correct? Now, if I multiply by minus on both sides, then what happens? Then we get minus 7 here and minus 5 there. Now tell me, which one is greater? Which one is greater? Make a number line. That may help you, right? If you make a number line, here we have 0, here we have minus 5, let us say, and this is my minus 7. The number on the right is always greater, right? So we know, well, this is greater. So that is what happens. When you multiply or divide by a negative number, the sign changes. Very important. Learning from this example. Make a note of this, okay? And always remember, when you multiply by a negative number, then the sign changes, correct? Therefore, solution for this is x should be less than 0. In this format, we can write this as minus infinity to 0, right? And you can never reach minus infinity, and therefore we have this kind of a bracket, less than 0. So within minus infinity to 0 is our solution for this equation. If you want, you can write in set form also, right? X belongs to all real numbers where x is less than 0, correct? That goes in. Now C and D are for you to do. F of x equals to log of 3 of minus x. So this is very similar to this. You can graph and figure out the answer, correct? Now, D is f of x equals to log 4 of x plus 10. So make an inequality like this and solve it. That will give you confidence, correct? Let's move on to the next set of questions. Thank you.